Okay, we are going to be reading Christine Honders' Let's Find Out, Physical Science. What is gravity? Now, I'm not going to be reading every single part, just certain excerpts that relate to our lesson today, but I highly encourage you to go check it out and read the book in your own time for your own learning. Anyway, let's get started. So, gravity as a universal force. Everything is affected by gravity. If you drop a book, gravity is what pulls it to the ground. Think about gravity like a magnet, pulling objects together or toward the earth. Mass is the amount of matter or stuff in an object. Which has more mass, a beach ball or a bowling ball or a baseball? Gravity keeps the moon in orbit around the earth and keeps all the planets in orbit around the sun. Gravity keeps pulling. Gravity pulls you back down to the ground after you jump in the air. Gravity can cause two objects to be attracted to each other. This attraction, or force, is called gravitational pull. The more mass an object has, the greater its gravitational pull is. Gravity is what gives an object weight. Scales measure the pull of gravity as weight. Okay, so Newton's law of gravitation. Isaac Newton, an English scientist, discovered the law of gravity. I think we know this story. Isaac Newton was sitting under a tree when an apple fell from the tree, and he wondered what made the apple fall to the ground. He knew there must be a force that acted on the apple, and understanding that force could explain other things, like why the moon stays in orbit around the earth. Newton wrote the law of universal gravitation. This law says that gravitational force exists between two objects in the universe, and the earth pulls all objects toward it at the same rate. If you dropped a feather and a piano from the top of the building at the same time, they should reach the ground at the same time, but air gets in the way, which makes the feather fall more slowly. Why does the piano fall more quickly? So I'll give us some time to think about that. Newton's ideas about mass and gravity. Isaac Newton said that gravity is a predictable force that depends on two things. The first being the mass. The bigger the object is, the more the mass it has, the stronger the gravitational pull is. This is why the piano falls quicker than the feather. Predictable means that you are pretty sure something is going to happen, and gravity is a predictable force because its effect can always be expected under the same circumstances. The Earth is very large and has a very strong gravitational pull. Even something like dust has gravitational pull, which is very small. Newton's ideas about distance and gravity. The second thing Newton said affects the force of gravity is distance. The farther apart two objects are, the weaker the gravitational pull is between them. If the Earth were as far away from the Sun as Mars, the gravitational pull of the Sun would be weaker because it would be further away. The force of gravity is what keeps planets circling around the Sun. Gravity in space is like a game of tug-of-war, with the Sun pulling the planets towards it and the planets tugging back. Earth's moon. The Earth is bigger than the moon, so the gravity of the Earth pulls the moon towards it. If the Earth had no gravity, the moon would travel in a straight line. Think about a ball attached to the end of a string. If you were to take it and spin it in a circle over your head, this activity is similar to the way the moon travels around the Earth and the way the Earth travels around the Sun. What would happen if you were to cut the string? Without gravity, would the same thing happen to the moon? Give us some time to think about that. Because of gravity, all the planets in the solar system orbit the Sun the same as the moon orbits the Earth. It's a star and a lot bigger than all of the planets put together, so even when planets are trying to fly away from the Sun is pulling them towards it. So we'll go ahead and skip ahead a bit here. So astronauts and centrifugal force. You've probably seen astronauts in movies floating in space and wondered, why doesn't gravity pull them down to Earth? Gravity is pulling on them, just the same as the rest of us, but they are moving sideways around the Earth in an orbit. The word centrifugal means moving away from the center, similar to our idea of tying a ball to a string and swinging it over your head. This force is a centrifugal force. It's the same force that seems to push you outwards when you're on a merry-go-round. What else can we think of that uses centrifugal force? Gravity affects the oceans too. The moon's gravity pulls on the Earth and its oceans, causing a regular pattern of tides as the Earth rotates each day. On the side of the Earth near the moon's gravity causes the ocean to bulge upward. This causes high tide on the beaches, and this tide changes as the Earth moves around the sun. Gravity also affects erosion on Earth. For example, dirt and rocks on the side of a mountain can be loosened by wind and rain. Then gravity pulls on the dirt and rocks, making them tumble down and cause a landslide. Gravity is a mysterious force. Isaac Newton wasn't sure why there is gravity, but his law is a theory that explains what gravity does. Even though people don't know why gravity works, you can see it working every single day. Even though gravity is pulling objects towards the Earth, some objects, like airplanes, seem to defy gravity, which means the objects remain airborne. Can we think of any other objects that stay in the air? Think about a guy in a parachute falling towards Earth. Gravity pulls the parachute and the man towards the Earth, but the parachute catches air as they fall, making them fall more slowly. Without gravity, when you jump in the air, you would never come back down. Our planet would have no moon, and the Earth and the planets would not be able to travel around the sun. So I encourage you to go read the rest of this book in your own time. But with these ideas about the force of gravity in consideration, let's go ahead and get into our lesson.